This is a Java DevOps end-to-end scenario demo using Microsoft's Team Services, Visual Studio Team Services, and Visual Studio Team Foundation Server. Today is January 24th, 2017. I am Paul Barham. I'm a program manager with Microsoft in the DevTools division. I'd like to introduce myself, and here's my email. If you have any questions about what you see today, feel free to reach out to me. You can also reach out to David Staley. He is my partner, and he is the software development manager for our Java or our cross-platform team. Today, I'm going to have a few slides to review what our product capabilities are. Then I'm going to give you a demo, and as I said, it's an end-to-end Java demo, starting with agile planning, going all the way through making some changes in a Git flow, doing a software build, doing a pull request, doing CI/CD on a software build, and having it deployed to the cloud. Some of the information that we have available to you, we have a YouTube channel, and on our YouTube channel we have a lot of different videos that you can look at. Let me open this up real quick for you and show you. So if you go to our channel on YouTube, you'll see several videos here. Actually, if you click and get to the point where you can view all, you can see many of our videos. Some of them are very recent, like this one was just recorded a week ago, this one was a week ago, that one was a month ago. So one that I want to point out in particular is this video here. So if you're interested in Java DevOps, there's another video on our YouTube channel that you should probably watch that involves using Docker and Azure Container Service. It's a little bit more of an advanced topic than what I'm presenting today, so I would watch the video you're watching now and then follow it up by watching this video here, again, the Java DevOps using Docker. So we invite you to go to our channel as a good source. So every time we release a new feature, we always make a video, we always do a blog post, so this is always a good place to go. This is not a space right here, that's an underbar, it's really hard to see. And then the other source of information you can get after today's video is this PowerPoint presentation. You can always go to this web address. And again, these are not spaces here. These are between Team Services, Java, and Overview. Those are not spaces. Those are actually underbars. So I just wanted to point those resources out to you. So as a kind of an introduction, 3 or 4 years ago, Satya Nadella took over as our CEO. And he immediately started making some changes, and he's been very consistent in the changes he's making in driving Microsoft to be more open and be more accepting of open standards, not necessarily hyper-focused on only Microsoft technology such as Microsoft Windows and C# and .NET, but in building tools that can empower every person in every organization on the planet to achieve more. We realize now we cannot do that just by hyper-focusing again only on Microsoft technology, so we're doing a lot of work in interoperability. So some examples we're doing at the company level, just showing that our openness and how we're now supporting cross-platform. We have Linux running on Azure, which is a big deal, so Azure is our cloud. We have Office running on an iPad. We've recently introduced the Bash shell, which is basically a Linux shell running on Windows natively, on Windows 10, and things like Bot Framework. So just kind of drive in a little deeper, if you look at the developer division within Microsoft, some of the things we're doing, we have this VS Code Advanced Editor. If you haven't heard of VS Code, it is a cross-platform Linux, Mac, and Windows editor. It is open sourced on GitHub, and you should take a look. We also have the .NET framework we've opened, and not only have we opened it, but we've got partners using it. So Red Hat is actually supporting the .NET framework on Linux, for example. And again, drilling down a little further, if you just look at our little division within the company, the Visual Studio Team Services division, kind of our motto is all developers, all languages, all platforms, and in a mobile-first, cloud-first way. So again, we are not just hyper-focused on C# and .NET. We are trying to support all developers, front-end, back-end, all languages, including things like Java, PHP, C, whatever it is, C++, and all platforms, again, Mac, Linux, and Windows. And some open source and openness cross-platform examples we have a build agent. So our software build agent that builds our software is written in Node.js, and it's open sourced out on GitHub, and it runs across all 3 of the platforms I mentioned. We have IDE plugins, one of which I'll be demonstrating today. Most of our plugins are open source, and almost all of them are written in Java and available on GitHub. We have a set of REST APIs, and we have a complete extensions marketplace where not only Microsoft, but many other third-party vendors are putting extensions out there to extend our product. So let's talk about Visual Studio quickly. When you have said Visual Studio in the past, you may immediately think about Visual Studio, the IDE, the integrated development environment that allows you to develop C# and .NET programs very easily, and a full set of suite tools to make it, like I said, easy and complete to do so. But we've extended the concept of Visual Studio. Visual Studio is now a brand. It's not just the IDE. So of course it still is the IDE, and the IDE is very popular, and we're still investing in that. But we've extended the Visual Studio brand to now include Visual Studio Team Services and also Visual Studio Team Foundation Server. I'll talk more about that. And then we also had the Visual Studio Code cross-platform editor that I mentioned. So what are Visual Studio Team Services and Team Foundation Server? So let's just start by saying that they're not IDEs, even though they share the Visual Studio name. We call it VSTS, Visual Studio Team Services, and TFS, Team Foundation Server. They do not include an editor. We assume you will bring your editor with you. So if you want to use Visual Studio, that's great. But if you want to use IntelliJ IDEA, or if you want to use other JetBrains IDEs such as CLion or PHP Storm or PyCharm, you can do that. Or if you want to use Eclipse as an editor, you can do that. Whatever you want to use, you bring it with you, and we're trying to support those. So that's one point. It doesn't include an IDE. And also, sometimes it can be confusing when you're thinking about marketing terms, but Visual Studio Team Services and TFS, VSTS and TFS, they're essentially the same product. They're on the same code base. The big difference is that Team Services, VSTS, is our SaaS offering, which means we have a hosted service that's running in the cloud, and you're able to access that via a web browser primarily. And TFS, Team Foundation Server, is really our on-prem offering. So it's something that you would host yourself using your own corporate infrastructure, and it would be probably behind your corporate firewall. And so that's the difference really. And Team Services is updated every 3 weeks. That's our sprint cadence. So we are pushing out features very quickly, and TFS is only updated once a quarter. It's more of a boxed product. So, what is Team Services and Team Foundation Server? The best way to think about it is an integrated suite of modular software development tools supporting application lifecycle management. ALM is kind of a dated term. Really, you can think of it as supporting DevOps. So it's a set of integrated tools that work together, that are integrated, that we have integrated as a company, and we provide as a suite. But each piece you can use on its own. So, for example, you could use our Agile planning without using our build system. You could use our build system without using our deploy system. You could use our build system and our test system, but not use deploy and vice versa. So we have all these different components. So what are the components? We have a version control system. We have an Emma code repository goes along with that. So you can think kind of like a GitHub kind of thing. And we do support Git. So we support Git and Team Foundation version control are the primary two standards we support. We have a bug tracking and backlog story management component to our product. We have agile processes like Kanban boards. We are able to have a software build process and coordination, continuous integration, continuous build. And we have manual and automated testing component. We have a package and artifact management component, and we have a CD component, release and deployment. So we offer a lot of these different capabilities. And again, you can pick and choose. You can use one of these components if that's all you want to use, and then you could use external components for the other part, or you can use it all. So basically, I'm going to stop there. Again, if you want to see the rest of this briefing, it is available from that link I gave you in the beginning. So let's turn our attention to our product. So before I do that, I actually want to go into what we're going to be demoing today. So the demo we're doing today is what we call Deep Space. It's an application we wrote in AngularJS and Java. And it's a very simple application. It's a visual application, so it's easy to demo. And it's just an application that draws basically youth flying through space. So you notice there's a sun here. You notice Earth is missing. We go straight to Jupiter, I believe, and then to Saturn. But there is no Earth. And so what we're going to be doing during the demo today, you'll notice, is we're going to be adding Earth. So that's going to be our task. So what I have here, I have this is all running on Linux. This is running in the Azure. This is running in our cloud. And it's running on an Ubuntu Linux. You can see here the Ubuntu name. And so I have it running on Ubuntu. I have the exact same application deployed to a Red Hat Linux server running in Azure, and then I have the application also deployed to AWS Elastic Beanstalk. So we have the exact same application deployed to two different clouds and on 3 different versions of Linux. Also today I'm going to be showing you kind of our integration with Jenkins. Jenkins is a very popular open source build and deploy system, so we have a full integration with Jenkins if you choose to want to use that. Of course, like I said, you can either use Jenkins or our build system, and you can interchange kind of between them, and I'll show a little bit of that today. But here is the Jenkins instance we're going to be using, and here are the 3 Jenkins build definitions that we're going to be calling. The one that specifically we're going to be demoing is this deep space CI build. So we're actually going to have this build will be triggered from our actions we're taking today in our system, and part of that will end up deploying to AWS. And so this instance you see here of AWS, the application here, is deployed from Jenkins, triggered from team services. And then we have a SonarQube instance. SonarQube is a static analysis tool. It's very popular. It's very good. And so here is the results of the last successful run of SonarQube on our software, on the deep space software. You can see that we've passed the quality gate. We've got some statistics here about complexity and about unit test coverage. The one thing to note here is everything's good now, everything's green, but the changes that I'm going to make in this demo are going to actually cause the SonarQube to pick up on several issues. We're going to basically introduce some problems into the code that SonarQube's not going to like, so this will eventually go red as part of the demo. So, all right, let's jump into kind of a little bit of the product. We're going to be looking at our team services product. So if I bring this up, this is our dashboard. So this is kind of the home page in your browser when you're looking at Visual Studio Team Services, and I've customized my dashboard, which you can do as well, and I've brought in some widgets so I can see some test trends. I can see the build history of our pull request builds both on our VSTS service and on Jenkins. I can see the results of the last CI and builds both on VSTS and Jenkins. You can see it's all green. I can see that all of our past releases have been successful, and I can see too, in terms of the persona that I am today, I am logged in as this XPlat demo account. So I have some stories assigned to XPlat demo, which is the account I'm logged in as. You can see I've got 3 product backlog items assigned to me and $1. Here is kind of the main menu up here of our product. We have, again, I'm on the home dashboard. We can go to code. Code will allow us to actually see my Git repository that has my code in it. So if I come in here and look at the files, I will end up seeing the software. So this is actually my Git repo. This is actually my source code. I can browse through it. We even have some basic editing capabilities, but again, the editing capabilities are not meant to replace an IDE. So this is my software. Then if you look at in the software, I can look at the number of Git branches that I have. Right now, I only have a master branch. I don't have any other branches. But some interesting things you can do on the branches. If I look at the master branch of my repository, I can click on this and I can actually go set some branch policies, and I want to look at this. And so the branch policies as they are set on this repo have it such that in order, we automatically build pull requests. And so if someone goes off and creates a topic branch, a feature branch from master, and makes some changes on that, and then they issue a pull request, which is a common kind of flow to do in the Git pattern. What will happen is whenever a team member creates a pull request, it's going to kick off this build. So I have a build defined called VSTS PR for pull request build, and we'll look at that build in a second. But that build will automatically be run when a pull request is issued. We always, on this branch, we always require a new build. You cannot complete a pull request until a new build is successful, and we block the pull request completion until there is a valid build. So again, you can't do it. Some other things you could do, you could have code review requirements. You could require a minimum number of approvals before completing the pull request. I don't have that checked because that's difficult to do in a demo situation, but I certainly could check that. You can also do things like have very specific fine-grained control where you can select a path, which basically says some section of my code, and you could pick some section of people or some subset of teams that say this team or this reviewer must approve in this section. So we have a lot of different fine-grained controls here. I'm not going to go over all of them because I don't have time. But basically, Now let's look at our build definitions. If I go to the build section and click on builds, these are the build definitions that I have for my project. I have several of them. I have a Jenkins CI build, CI being continuous integration. I have a VSTS CI build. I have a VSTR or pull request build. This is the one, this build that I'm hovering over here is the build that will be triggered when a pull request is issued. So let's go take a look and see what's in that build quickly. And as I go in here, I can edit the build and I can see what's going to happen when this build is kicked off. So this is our build system. It's easy to create builds and it's easy to include things. Right now I have this build definition created. And so for Java specifically, we support Ant, Maven, and Gradle. This happens to be a Maven project. And so the very first step in this build is to build using the existing POM file that's part of this Maven project. I will do a clean and a package on that. I will also run JUnit test for this Maven project, and I will publish the results of those to a summary, which we can look at. I'm also going to do some code coverage analysis using the JaCoCo product. We also have available Cobertura and JaCoCo are the ones we support for Java, so I'm going to do JaCoCo. And then in addition to the build doing the JUnit and the code coverage analysis, I'm also going to do a SonarQube analysis. And this is a kind of an interesting beta or preview product. And so what I'm going to be showing you today is not built into the product, it's a preview product. The code is out on GitHub. You can actually build it and bring it in as an extension. But we have this ability to have SonarQube do an analysis of the code at the time that you do a pull request. And if it finds any warnings or suggestions that it thinks you should do based on the rules in SonarQube, it will inject those comments into your pull request, almost like a reviewer, like an automated reviewer. So I'm going to be demonstrating that capability. Again, if I go back and look at all the builds in here, this is the one that will be kicked off when a PR is done. When a PR is accepted and merged into the master branch, that is when our CI builds will be kicked off. Both of these CI builds will be kicked off automatically because they are configured to do so when a merge takes place. And so the Jenkins build and the CI build from Team Services will kick off in parallel. Once those builds are complete, then we have some release definitions that will also trigger, because this is a full CI/CD demo I'm showing you today. So on the deploy side, once the CI builds are complete, both for Jenkins and for VSTS, artifacts will be created, WAR files to be deployed. And then we have essentially two CI deployment tasks. We have one that takes the Jenkins results and will deploy those to the Ubuntu server I showed you earlier running in Azure. And then we will take the WAR file produced by VSTS and deploy it to the Red Hat. So again, the Jenkins WAR file that's built for CI will be deployed to Ubuntu. The VSTS will be deployed to Red Hat. And on Jenkins, the CI build will also trigger the AWS release. And so there's going to be a lot happening, and sometimes it's hard to see it all. But that's kind of the overview of the product. You'll see some other things up here. Again, I showed you a little bit of code. I showed you a little bit of work, a build release. We also have the test section that I'm not going to spend a lot of time on today. But that's basically the product. So let's go ahead and start the demo in earnest. And so if we go to the work section, I can actually look at my Kanban board for my team. And so this is my Kanban board. Let me move this out of the way. Okay, and basically if I look at the backlog, I can see that I've got several stories assigned to me. And even at the story level, you can click on this, and within the story, I have certain tasks that I need to do. And so maybe a PM or another stakeholder has used our product, and they have created some backlog stories. And so now I'm coming in, say, in the morning as a Java developer, and I'm saying, what do I need to do today? So I go to my backlog, and I see what's assigned to me, and I say, okay, I'm going to do this task. And so I'm just going to grab that task and bring it onto the Kanban board, and now it'll show that I'm in progress. So if anybody wants to kind of check what's happening right now, they could look at our team Kanban board. And again, this is a very oversimplified board just for purposes of the demo, but they can see that XPlat demo is now working. He's working in the in progress as add earth. And I did not put it up in the critical section. I put it down in the normal swim lane for the task. And so what I'm going to do now that I'm working on this, one thing we have is you can actually create a Git feature branch from the work item. and it'll associate it to. So from here, I want to create a new Git feature branch that I'm going to go work on. And I need to give it a name, so I'll call it Java Demo Jan to make sure it's unique. And I'll go ahead and create the branch. When I do this, it flips us over to the code section of our product. Now we're looking at I am in the Java Demo Jan branch. So this is actually the branch that I just created. I can actually see it. From here, I can actually go to this clone button up here and clone it. Now I can clone into many different IDEs. I could clone it into Visual Studio. I could clone it into Android Studio, C-Line, all these things. But this particular one I want to clone into IntelliJ IDEA. So what's happening now is that IntelliJ IDEA will start up. It takes a few seconds to start up, but when it starts up, it will come up, and first of all, it's going to ask me for my master password of my secrets. So I'll put that in, and it will ask me, okay, it automatically has put the URL in. I don't need to know the URL. That's just part of the clone operation. It's asking me where to put it, so I'm going to put it in. I create a unique name here, and I will clone it. So it's actually using our plugin. So the Visual Studio Team Services plugin is installed on this instance of IntelliJ IDEA, and our plugin is going out and it's cloning the repository. It auto detects that it's a Maven project, and so I say, okay, that's great. There's multiple projects in this repo, so I want to tell it to search recursively. I don't want to use the UAT one today, so I'm going to uncheck that. And I'll go ahead and complete this. And so what's going to happen is IntelliJ IDEA, again, using our plugin, is going to go out, and you'll see that it's checking out our repo. And so it's just going to come up automatically already in that Java Dem Jan branch that I created. So I'm going to be sitting in the right branch. The source code is going to be there. And so now I am on my local machine working in a local branch. Okay, so it's almost done. And it looks like it's done. So now I can actually go in and make some changes. And so the changes we're going to make, I didn't look at them very closely or mention it, but the story that I put in progress said for us to add Earth to the demo, because as I shown you before, Earth was not part of the demo. So I know how to do that. I need to go in here and find the source code and go here. So the changes I'm going to need to make, first of all, are in this file. And in this file, I've got a couple things. So the first thing I'm going to do is find the code that's going to add Earth. And the code that adds Earth is simply right here. So I just need to comment this code in, and that will include Earth. And that's a pretty simple change in this file. That's all I really need to do in the code part to add Earth. I'm also going to need to go change the unit tests that are testing for things, because the unit test will fail if I don't go change them to now let them know that Earth is there, there's a fourth planet. But one other thing I'm going to do to show you the SonarQube integration we have and show you the PR injection comments we have, I'm going to put some space between me and that dummy comment. So I think SonarQube will probably give us a warning about a dummy comment or comments are necessary. I'm going to add some things that I know SonarQube does not like cloning a member function. This should give a warning. It has no real effect, but it'll give me a warning on that. Also, SonarQube. Let's see, down here it will give me a warning if I have to-dos in the code, so I'll add a to-do. And seems like there's one or two other ones down here. Oh, yep. And then here, if I add a variable, and this variable is not used, first of all, it'll give me a warning. The fact that this is not used, it'll also tell me that this is not the proper way to do an assignment. And so I'm going to get some SonarQube warnings. I think that's everything I need to do in this file. So I will save this. And then, as I mentioned, I need to go into the unit tests as well and update those so that they know that I now have Earth. So instead of asserting that there's 3 planets, I need to assert that there's 4. One change. And then I need to comment in this member function. And then there's one down here I need to comment in as well. So basically, these changes I'm making are the changes that I would make to add Earth. And so let me save that. And now So everything I just showed you about editing this, that's built-in capabilities into IntelliJ. Our plugin doesn't really add any value there, but where our plugin added value was doing the checkout, doing the clone, doing the association to the correct Git branch. And now I'm also going to be using our plugin again. So if I click on this version control down here, it says that 2 files have been modified. That's exactly what I expect. So I'm using, this is our plugin. If I go here and say I need to do the commit the changes, it says the 2 files that have been done. And then again, our plugin has this capability to do an association. So I want to see what work items I'm associating. So I am adding earth. That's one thing I'm doing. Remember, I had put that in progress. But I also, while I was in there, I went ahead and added elements to the code to trigger SonarQube. So I'm going to select that as well. And I say OK. And so it's going to add those to our commit message. It adds, it does an association with those work items to this commit for traceability. So now I'll do a commit. And I just want to do a commit here. And then now that I've done the commit, 2 files are committed, I want to go issue my pull request. So if I go to pull request, one thing you can see here is I have in team services, our plugin has gone out and contacted the server. I don't have any current pull requests that are assigned to me. I don't have any requested by me. I can also look at work items and see what work items are in team services without having to jump back to the team services. So I'm still within the IntelliJ plugin, or IntelliJ, and our plugin allows you to look at your work items, create new pull requests. So I'm going to do that. I'm going to create a pull request. Now when I create this pull request, we're going to then go jump back to our team services view and see what's happening in team services. Because remember, we got CI/CD set up. And if you remember, when a new pull request is created, a build is kicked off. So I come back over to team services, and it says a build is in progress. So I want to go look at that build. And this will be the PR, the VSTS PR build that I mentioned earlier. So it's the VSTS PR no artifacts build. And so our build has in fact kicked off. And if you notice, it's running on an Ubuntu server. So our build system, we have an agent that you can install, and the agent is cross-platform. It's written in Node. I mentioned that earlier. And I have installed this agent on an Ubuntu build system running in Azure. You can install it on Linux, you can install it on Mac, and you can install it on Windows. And that machine you install it on could be in the cloud, or it could be on your premises, either way. So it's now building the Maven project on that build system, and when it's done, it will have run the unit test, and it will have done the JaCoCo code coverage, and it will have run SonarQube to do the injection of comments as the code has been analyzed. And so you see it progressing here along. So once this completes, and it should be fairly quick to complete, maybe a few seconds, we will jump back and look at the pull request to see if SonarQube actually did inject any comments and what those comments are and what we should do about it. So again, this will be running. You can see too the history. This shows the last build. If I hover over it, if I can stay there, the last build took 105 seconds. We're currently at 87 seconds. So we would expect that, in another 25 seconds, this build's going to be complete. But you can kind of see the history here of the last builds. That one ran for 2 minutes in the history here. So it's getting toward the end of the build. And again, this build is happening on a different machine. So the output of that machine is being piped into our cloud. So it's done now. So if I go look at the pull request, if I bring that up, let me see, go find it. Is this the right one? Let me make sure. Okay, so this is the pull request. Okay, so this is the pull request, and so now the build succeeded. So, and we could tell that because I went green while ago and it completed. So if I look on here, SonarQube, it shows me the diffs between the files. First of all, you can see where I commented in some things, but it's also giving me feedback. It's saying, hey, use big decimal value of instead of doing this assignment the way you're doing it. I don't like the way you're doing it. And that's a rule that's defined in SonarQube for Java. It's one of the rules. If I look down here, it says, don't do this clone. So remember, I commented that in so that I could get this feedback. It says remove the clone implementation, use a copy constructor in instead. And likewise, remove this unused variable. Remember, I introduced the variable. First of all, it's not used, so I shouldn't be having variables that aren't used. I need to document this public method that I did. There's no documentation for it in the code. So SonarQube did this analysis, and SonarQube determined that these are things that need to be fixed in the code. Whether there are errors and will block the build is different. I did not set it up that way. I did it more or less to do warnings. But anyway, you can see I'm supposed to use super clone there, remove this useless assignment. I mean, if you're not going to use a variable, then the assignment's useless, and add the override annotation when you do this type of clone. So I got all this feedback. All that was automatically generated by SonarQube. And again, this is a preview capability. This is a capability that's out on GitHub. You can build it and install it as an extension and use it in your build task, and that's what I've done here. This is not built into the product today, but we are working with SonarQube to continue to improve our integration with them, and they will be taking over the ownership of those and driving this forward. So that's the pull request. So I'm going to go ahead, now that I know the build succeeded, let's go over and look at the build. Let's look at the results of the build really quickly. And so this is what we call the summary page of the build. So the build succeeded. Here are the test results. I have 10 unit tests, all passed. That's good to know. And I have pretty good code coverage. This is the JaCoCo code coverage. It shows that I've got things covered pretty well. And this little warning here is kind of just an anomaly because I said we were using a preview capability of that injection. So this is actually, I would call it a little bug we need to go fix, but it's not that big a deal. So this is the build. So if I go back to the pull request, I can approve it, first of all, as an approver. So now it's approved, and I can also complete it. Now when I complete this pull request, first of all, a couple of things are going to happen. The branch, one of the options to the complete, the branch will be deleted. And the commits will be what we call squashed or merged in. So, but when I do that, it's going to kick off one of the CI builds. Matter of fact, it's going to kick off 2 of the CI builds. There'll be a CI build that happens within VSTS, and there'll be a CI build that happens within Jenkins. And so from here on out, things are going to happen fairly quickly. What's going to happen is I'm going to complete the pull request. 2 CI builds will kick off in parallel. We'll go quickly look at those. The Jenkins CI build will produce an artifact that will be brought back into Team Services. The Team Services build will create an artifact as well. The completion of those CI builds will then kick off a deployment. And the Jenkins artifact that's created will be deployed to the Ubuntu server using Team Services. The VSTS build artifact, the WAR file that's created, will be deployed to a Red Hat service, and then Jenkins out when we kick off the CI build. When the build is complete, it will use its pipelines capability, and it will then start a deployment of its own local WAR file to AWS. And so that's kind of what we're going to see here. So I complete. Okay, I'm going to delete the branch, and I'm going to squash. So when I do this, it's completing it. Okay, now the PR is now complete. So if I jump over to our build system, there should be 2 builds that are kickoff, like I said. If I look at what's queued, down here at the bottom, you'll see there are 2 builds in progress that just started. One's a Jenkins CI build, and one's the VSTS CI build. So if I look at, let's look at the Jenkins one pretty quickly and see if it's actually kicked off. That's not what I meant to do. So again, let's go back. I could have clicked on that. So if I look at this Jenkins one, it's in progress. If I look at this one, you know, it tells it, okay, it actually is going. So it's actually queued the Jenkins job. So it's actually, this is the Jenkins output. If I jump over to my Jenkins instance, we should see that build in progress. And then in fact, we do. Look at there. So this Jenkins job, this is in Jenkins, it's kicked off, it's building. As soon as the CI build is over, which only takes a few seconds, what it will do is the artifact that's created, the WAR file that's created, will be pulled back into Team Services. And then Jenkins is going to then kick off this deployment to AWS, which you see is kicking off now. So it's in the build queue, this will be kicked off. So Jenkins is off doing what it's supposed to be doing. It created the WAR file from our change, and now it's deploying to AWS. And so if I jump back over to Team Services, we see that Jenkins job has completed. And if I jump into the other build, we'll see if the build is completed for VSTS. Remember, there's 2 running in parallel. Let's see if that one's completed. It still says the VST one is still in progress, so let's go look at that and see where it's at. It should be well on its way to being complete as well. So the build is actually done. Now what it's doing is uploading some of the files and producing the artifact and storing the artifact at a place that the deployment task can then go find it. So it's almost done as well. So okay, it's done. So now if I go over to our releases, I should see, if they're not already done already, at least one of them, I should see 2 releases. Okay, so the Ubuntu one is complete. So the one that was triggered from the Jenkins build the Ubuntu deployment is complete. It finished a minute ago. There's also one in progress deploying to Red Hat. So if I come over here, I can actually look at it in process. It's waiting for an agent to deploy. And so it should kick off in just a few minutes. In the meantime, my Jenkins instance is still busy excuse me, deploying to AWS. This deployment to AWS takes a while to deploy to Elastic Beanstalk because from Jenkins it does a deployment and then it does a verification step. And so it takes quite a while. You can see the last duration took 7 minutes. And so it's going to be a few minutes before it's complete. If I jump back over to Team Services, let's see where the release is at now. Okay, it has an agent. It's now securely copying the files to the remote machine. So in terms of supporting Java and in terms of doing deployment, what I'm using is what's called the SSH file copy. We have multiple ways you can deploy to a server. And I didn't mention this before, but all the servers are running Tomcat. So both the Ubuntu, the Red Hat server that are running in Azure, they're all running a Tomcat server. And Elastic Beanstalk is also running Tomcat. And so we have multiple ways to deploy to Tomcat. We have multiple ways. That deployment is now complete. So, but while I'm sitting here and talking to you, we have multiple ways to deploy Java. We can use FTP, we can use SSH file copy, and we also have a Tomcat deployment task. Those are 3 ways that you can deploy. We also have we support JBoss and Wildfly. So we have a JBoss deployment task if you're using that system, and we also are currently writing a WebSphere. So again, this is a January 2017 demo, and so by March of 2017, you should see us publish a WebSphere. And so once we do that, we've got pretty much all the deployment steps, or at least the common ones that are popular. So now that these deployments are done, the only one that we're waiting on is the AWS one from Jenkins. But while we're waiting on that, we can go ahead and show you. I can reload. So if I come up here, this is the Ubuntu system running in Azure. So let me reload that. And if we're successful, we should see that Earth should come up after the sun. So there's the sun, there's Earth. So my change was automatically deployed to the cloud. If I go to the Red Hat system that's running in Azure and reload it, its deployment is also done. So there's the sun, and I should see the Earth come up. Boom, there it is. And so again, all we're really waiting on is the AWS deployment. So while we're waiting on that, let's look at the results of the Sonar Cube. So Sonar Cube was loaded. I haven't done a refresh here. So this was based on the last successful time I ran Sonar Cube prior to making all those changes. But all those changes that I made, remember, I added a bunch of warnings and errors or vulnerabilities or whatever that it's not going to like. So if I refresh Sonar Cube now, it's going to come back and say you got some problems. It's going to say that you have a larger tech debt ratio than we want. You've got 32%, you said 5. And so if I look at like new bugs, like what bugs do I have, I can come in here and it says I have 1 in this image service where I made the change. If I click on that and go down here and look, it's going to complain about this clone and say this is the bug, this is a problem. And remember, you've seen these comments before. These are the comments that were injected into the pull request. So I knew this was going to happen. And so if I had responded to the pull request comments that SonarQube gave me by going in and making changes at that time, I would have gone in and fixed these, and we would not have had these problems. So it's, like I said, it's like an automatic reviewer. Now, why did the build complete when it had all these errors? It was because we told the build to only treat this as suggested things and to continue on error. So the SonarQube was treated more as a recommendation and not as a terminal problem. You can set up the build so that they will fail if SonarQube gives you these warnings. I just didn't do that for the demo. So let's see where Jenkins is at. Still finishing up its deployment. While it finishes up, let's look at some traceability things here. If I go to the deployment, the release, and go here, and again go to, let's open that release back up. This is the summary of the release, and so you can see if you were like, okay, the release broke something. Okay, we're now sitting in production, and somebody noticed there's a bug, and they say, when was this bug introduced? They can come to the release and say, okay, this was the release that happened to the Red Hat server. Maybe we found it on Red Hat. You know, you can see that this release was triggered by a CI build. So this was a CI/CD pipeline, and so it was automatically triggered. Nobody did a manual deployment, so you can see why it was done. It was done 5 minutes ago, and you can say what build did this, and you can see that the release is triggered by build 348, so I can trace backwards what was build 348. If I go to build 348, it'll give me the summary of that build, and I can see, okay, well, what was going on here? Well, I see the SonarQube analysis failed, so again, I could have set this up so this build would have failed there, but we didn't. But maybe that's part of the problem. Maybe whoever did this, and so you can see what was done. This was done. This is the definition that was run. It was done on master, so you can see, you know, this is a master build, and here is the commit that was done. So I can click on this commit and say, well, what was done here and who did it? It takes me back to the pull request, and I can see all the different changes that were done. Or I can see the history on this file, and you know, say what's going on here. If I go back to the build, you can actually that was basically it. So if I go to the commit, I can tell what was done and say, okay, this is, you know, I can see also the XPlat demo did this thing, and I can see there's 2 work items associated with it. I can see that there was if I click on this is actually the pull request, sorry, that was done, and from the pull request, you can see the commits that were part of this pull request, and these were the commits. I can click on that, and basically I'm showing the traceability from the end back to the beginning, and it goes back and again shows you all the work items. So you can see which work items they were working on that caused this bug. You can see what the changes were, and vice versa. So we have full traceability from end to end of what was happening. It's very easy to find out what's going on. Let's check our Jenkins build quickly. It says it's done, so I should be able to reload my AWS instance of this, and I should see the sun and then see the earth. So it takes maybe a little bit to load the images, but there goes the sun, and boom, earth. So I showed you a full CI/CD pipeline. Now there's one remaining thing I need to go do, and that is to close my story. So if I click on this, and I'll just go here for now. If I go back to my Kanban board, you know, I have actually gone in and looked at all the results, and I verified that I did add earth. So I'll say, okay, I'm done with that. If I had only done one task or the other, I could have just said one of these are done, but both of those are done. So I can do that. And the other thing I did was I added elements to the code to trigger QR. Even though I never put it in process, I did do that task. So I'll move it over here to done. So this is kind of showing you, again, the end-to-end usage of team services in a Java DevOps CI/CD situation where I actually used my backlog to determine what stories I was supposed to be working on. I put those in progress. I created a get branch, a get feature branch. I went and made some changes in that get feature branch. I then created a pull request. The pull request initiated a pull request build that did some validation to make sure I haven't broken things. It also triggered an extension that we have that injected SonarQube comments back into my pull request, kind of as an automated code reviewer. I reviewed all that. I determined that I was happy with it, so I completed the pull request, which then kicked off a continuous integration, continuous deployment build. So I had 2 CI builds. One was in Jenkins that was triggered by our system, and one was within our system. Each one of those produced an artifact. As soon as those builds were successfully complete, that triggered a deployment in our system. Our CD system, our deployment system, deployed the Jenkins created war artifact to Ubuntu in Azure, a VM running Tomcat, and then the VSTS artifact was deployed to Red Hat. again running in Azure, running a Tomcat server. And then Jenkins, once it was completed building its artifact, it used its pipeline capability to kick off a deployment within Jenkins to deploy to AWS Elastic Beanstalk. And all three of those were done. You can see traceability there. If you look at the Jenkins one, I didn't really point this out, but in Jenkins you have traceability as well to what was done. We can go to the build. So let's go build history. And we can see that this one was done, build 53. Let's go look at that. You can see that this was kicked off for this repo, and the build number was number 64. It was started by an upstream project. They'll go back and look at this one, because that's the deployment task, build 63. It produced 2 build artifacts. The reason it was kicked off is because of a pull request from team services, and so you actually have traceability from Jenkins over to team services, and you can actually click on this, and it actually take you to our system, and it probably asks me to log in. I'm not going to go through that, but that takes you back to the system, so you can actually do traceability from Jenkins. I will point out that Jenkins is running with our plugin, so we have a team services plugin that is in Jenkins. You have to have that installed. I also had several other extensions installed in team services due to this demo. One was the SonarQube injection. So that's basically the end of this demo. Again, if you have any questions, I will bring back up the slides very quickly and say that, again, this slide shows you some really good resources. And if I slide down to the bottom of the slideshow, excuse me, here are some other resources. So if you have questions, we encourage you to reach out, use our Java subsite of the Visual Studio website. You can also contact us on social media, both on Facebook and on Twitter. Here's our handles. And here are some of the GitHub repositories that I mentioned. Our IntelliJ plugin that is written in Java is available for you to look at and contribute to. We also have a plugin for Eclipse. We have a plugin for VS Code. So those are the IDEs that we have plugins for. There's a lot of other open source in our Microsoft account. I thank you for your attention and enjoy.